In this problem, it says, find the minimum and maximum of the function f of xy equals x plus y squared subject to the constraint 2x squared plus y squared equals 1. So take a moment and try to solve this problem, and we'll go over the answer. Okay, so when I see this question, it says that I'm supposed to find the minimum and the maximum of a function, right? And it's subject to this constraint. So what that means is I want to know the biggest and smallest values of this function, f of x, y, but your x and y can't be anything. Your x and y have to satisfy this equation, 2x squared plus y squared equals 1. So what method does that suggest that we use? Lagrange multipliers, right? Because your x and y have to range, they have to stay on an ellipse. So it's not like you're finding the largest and smallest values of x and y over a region, right? It's on an ellipse. So it's this, it's like an ellipse like this. If you wanted to find the largest and smallest values kind of inside the ellipse, then you would do the stuff with the critical points, but we don't have that. We're only looking at what happens when the function is restricted to this ellipse. So that's what's telling us that we should use Lagrange multipliers. So how does that work? So Lagrange multipliers is when you have a function that you're trying to maximize or minimize, it's f of xy, and then it's subject to this constraint g of xy equals a constant. So in this case, your g of xy equals 2x squared plus y squared. And then the theorem says that when you have a maximum or a minimum, you have to have the property that the gradient of f is some scalar multiple of the gradient of g. That has to happen. And of course, you also need 2x squared plus y squared to equal 1. So let's write out the equations you get by taking the gradient and setting it equal to lambda times the gradient of g. So the gradient of f is 1 comma 2y. The gradient of g is 4x comma 2y, right? So when you set the gradient of f equal to lambda times the gradient of g, you get these two equations. You get 1 equals lambda times 4x, and 2y equals lambda times 2y. Now you have to be careful and not, well, okay, so you have these two equations, and then you also know that 2x squared plus y squared equals 1. So these are the equations you have to work with, and you have to solve for x and y. So when you have something like this, you have to be careful with the algebra, and especially when it comes to dividing by things, you want to make sure that when you divide, you're not dividing by 0 accidentally, because that's not allowed. And one thing I like to do, so there's lots of different ways to do the algebra to solve for x and y, but the way I like to do it is I like to always take these equations that you get by taking the gradient of equal to lambda times the gradient of g, and then cross multiplying like this. So when you cross multiply, you get that lambda times 2y is equal to lambda times 8xy. In other words, lambda times y equals 4 lambda times xy. Okay. Now what we would like to do is we would like to divide both sides by lambda to cancel out the lambda. But you have to make sure that lambda can't be 0. So you have to argue that lambda can't be 0. In general, lambda might be 0. But can lambda be 0 in this case? If you plug in lambda equals 0 into either of the first two equations, does anything go wrong? Yes, right? Something does go wrong, because if you plug in lambda equals 0 here, you're going to get 0 times 4x, that's 0, but there's no way that can equal 1. So lambda is not equal 0. So let's call this equation 1, 2, and 3. Because then 1 implies that 1 is equal to 0, which is obviously not true. So you can divide both sides by lambda, and then, so this is an implies symbol. You get y is equal to 4xy. And notice that I'm not dividing both sides by y, because if you divide both sides by y might be 0, and there's nothing stopping y from being 0, right? If you look at this third equation, it is possible for y to be 0, and then you're going to get some values of x. So what you do is you need to subtract and factor things out, not divide. You get 0 on one side. So let's subtract y from both sides. You're going to get 0 equals 4xy minus y. Okay, I'm just going to write the stuff with the variables on the other side just to make it look like this. And then I'm going to factor out the y and get y times 4x minus 1 is 0. So in this case, either y equals 0 or 4x minus 1 is 0. In that case, x is 1/4. So now you have to figure out what happens when y is 0 and what happens when x is 1/4. So when y is 0, okay, now you have to plug it into the third equation. You get 2x squared plus 0 squared is 1. That means that 2x squared is 1, x squared is 2. And remember, you actually get two values of x here. You get plus or minus 1 over the square root of 2. No, you get plus or minus the square root of 2. Wait a minute. Yeah, sorry, this is 1/2. And then when you take the square root, you get plus or minus 1 over the square root of 2. Okay, because there are two square roots. All right, so then you have 1 over root 2, 0, and negative 1 over root 2, 0. What about when x is 1/4? Then you get 2 times x squared plus y squared equals 1. 1/4 squared is 1/16. 2 times that is 1/8. 1/8 plus y squared is 1. Subtract 1/8 from both sides. You get y squared is 7/8. So y is plus or minus square root of 7 over 8. So now you get these points, 1/4 the square root of 7 over 8, and 1/4 negative square root of 7 over 8. So these are the four possibilities for where the max and mins are. Okay. The maximum is one of these, it occurs at one of these 4 points, and the minimum occurs at one of these 4 points. So what do we do to find which one gives you the maximum and minimum? We have to plug them into the original function that we're trying to maximize and minimize, right? The question's asking, you have this function, what's the biggest and smallest values of this function? And we know by the Lagrange multiplier stuff we did that it has to be one of these 4 points. So if you just plug them in and see what the actual values are, then that'll tell you which one's the biggest and which one's the smallest. So we have these 4 points. Why don't we just make a table just to keep things organized? So let's make a table for A, B, and then f of AB. So f of AB is A plus B squared. Okay. So if you have the point, or you can also use XY instead of AB. It's just AB, use it for constants instead of XY, think of as variables. Anyway, so 1 over root 2, 0. Negative 1 over root 2, 0. One fourth square root of 7 over 8. 1/4 negative square root of 7 over 8. We plug them all into the function, and what do we get? For the first one, you get 1 over root 2 plus 0 squared is 1 over root 2. For the second one, you get negative 1 over root 2. For the third one, you get 1/4 plus 7/8, which is 9/8. And then for the last one, you get 1/4 plus 7/8 also, because the negative, when you square it, cancels. And then you get 9/8. So which of these is the biggest value? See, notice that 1 over root 2, the root 2 is bigger than 1. So 1 over root 2 is less than 1. So you know that 9/8 is bigger than that. So the maximum value of the function is 9/8. Oops. And the minimum is what? Negative 1 over root 2, because it's negative. The other ones are positive. And remember, we're finding when it says the maximum and minimum of a function, the answer is not going to be these. It's not going to be one of these points. It's going to be one of these numbers. Because if you think of f of xy as the temperature at the point xy, right? It's saying what's the hottest temperature, what's the lowest temperature. We want values that are actually going to be temperatures. So we want values that are actually values of the function. The question isn't asking for the points. So the final answer is the maximum is 9/8 and the minimum is negative 1 over root 2. Okay. So let's just review. So this problem didn't say to use Lagrange multipliers, but we're supposed to figure out that that's what we're supposed to do. And we're supposed to figure that out. What gives it away is that you're trying to maximize and minimize the function subject to a constraint which is given by an equation. That's your G in the Lagrange multipliers. So you set up the Lagrange multipliers, and then what I like to do is you take the equations with the Lagrange multipliers and then cross multiply, and then you show that lambda can't be 0 because you get an issue. So in this case, the first equation is an issue of lambda 0. Lambda can't possibly be 0 because the first equation wouldn't make any sense. And then once you know that, you can divide by lambda on both sides. That cancels out the lambda. And then you get y equals 4xy. And again, we don't want to divide both sides by y. Actually, if we divided both sides by y, we would have ended up missing, right, the minimum. You have to factor instead, and then set each of the terms. Once you have a product equals 0, you set each term equal to 0, and then you solve. So you get the y is 0 or x equals 1/4. That's what you get from the first two equations. And then when you have those, you plug those into the third equation to see what you get. So then you get these 4 points, and then you test them by plugging them into the function, and then you know what the max and mins are. Okay. And that's all I want to say in this Lagrange multiplier example.